right, friends, here it comes, the next installment of the special topics. This is functional analysis round 2. We're coming back to all those F prime, F double prime relationships, and we're going to push the thinking a little bit more. Before we get going, today's secret word is Kermit, as in Kermit the Frog. And Jackie Baron, I will do my best to use my pretty handwriting today. Anyway, okay. So before we get started, a couple of the name theorems that I want to make sure that you have ready access to. One of them is the fundamental theorem of calculus. Fundamental theorem of calculus says that f of b equals f of a plus the integral from a to b of f prime of x dx. This is the theorem that I would tell you guys. It's the value of the function at the end of the interval is equal to the value of the function at the start of the interval plus the integral of the derivative. Said another way, the final value is equal to the initial value plus the total change. Some people use the or express the fundamental theorem of calculus this way. They say the integral from a to b of f of x dx is equal to capital F of b minus capital F of a. These mean the exact same thing, just presented way. Okay, let's keep going. Now there's the second fundamental theorem of calculus, and this is the one, and it's so funny because we talk about it again and again and again, and everybody always looks at it like it's the first time they've ever seen this. This is when you take the derivative of an integral of a function, this is f of t dt, and you're evaluating from a constant to a variable. This looks crazy. Look at all that calculus notation. The derivative of the integral of a function from a constant to a variable. All that happens is you get the original function back being evaluated at the new variable. That's it. All right, there is this extended second fundamental theorem that says if you're taking the derivative of the integral of a function from a constant, and now your upper limit is another function, that you get the original function evaluated at the new function times the derivative of the new function. That's the extended second fundamental theorem of calculus. Okay, these are the big three. We're going to use them a lot. Let's get going. This first question comes straight from the 2011 AP exam. This is question number 4, so relatively recent. And I'd say this is a pretty standard question. I would expect that a question like this you all should do quite well with. Okay, the continuous function f is defined on the interval -4 less than or equal to x less than or equal to 3. The graph of f consists of 2 quarter circles and 1 line segment as shown in the figure above. So this is the graph of f, and then they define a new function that they're calling g of x. G of x is 2x plus the integral from 0 to x of f of t dt. Okay, we've got a quarter circle here. We've got a quarter circle here. And we've got a line over here. These are some of the pieces that they've told us. Find g of -3. Okay. G of -3 just means evaluate g at -3. Said another way, everywhere there's an x, I'm going to plug in -3. I've got 2 times -3, well that's -6, plus the integral from 0 to -3. This just means go find the area. Now, for the astute calculus student, you're going to notice that the limits of integration are in the wrong order. So you're probably going to want to switch them so that now you're going from -3 to 0. And that's okay. Just be sure to change the sign. Now, how do I find the area from -3 to 0? What I have is I have a circle, or I have a quarter circle. So what I need to do is say, okay, this is going to be -6 minus 1/4 the area of the circle, Area of a circle is pi times r squared. I can see in this problem that the radius is 3. So if I simplify, we're going to get -6 minus 9 pi over 4. And at that point, you've just locked in your first point. Not too bad. Okay. They then ask us to find g prime of x and evaluate g prime of -3. Well, what do we know? G prime of x means go take the derivative of g. That means I need to find the derivative of 2x plus the integral from 0 to x of f of t dt. When I'm taking the derivative of the sum, imagine distributing that derivative through. The derivative of 2x is 2, plus I need to now take the derivative of this integral, the derivative of the integral of a function from a constant to a variable. This is the second FTC. That's where you finally get to use that. What we're going to get is 2 plus f of x. This is what g prime is equal to. And you picked up another point. To find g prime of, what was that? G prime of -3. Well, g prime is equal to 2 plus f of x. G prime of -3 is going to be 2 plus f of -3. To find f of -3, I'm going to go over to my circle, and I see that at -3, the value of f is 0. So I've got 2 plus 0, which is 2. And that concludes part A. That was worth 3 points, and I would expect that for most of the students in my calculus class, this is going to be the kind of problem where you can earn pretty much all of the points. Let's keep going. Part B. Determine the x-coordinate of the point at which g has an absolute maximum on the interval -4 less than or equal to x less than or equal to 3. Now, I know we talk about this a lot. These absolute maximum questions are always going to require a little bit of work. So part B, if g has an absolute max on the interval -4 to 3, what I need to do is I'm going to have to evaluate g at the endpoints, and I'm also going to have to find the candidate. The candidate is the place where your function might have a relative max. G has a relative max. Well, what that means is that g prime has to make a change from positive to negative. What do we know about g prime? Well, I think we just showed that g prime is equal to 2 plus f of x. So we need the graph of 2 plus f of x to make a change from positive to negative. Now here's where things can get a little bit tricky. This is the graph of f. What does the graph of f plus 2 look like? Well, that's just going to be a matter of shifting the graph up 2 spaces. You could think of it that way. I think it's going to be a little tricky to figure out where exactly does this change happen. You could also say, well, let me see where is it that 2 plus f of x is equal to 0. That means that f of x is equal to -2. Where is it going to be true that the y value is -2? This one you're going to have to do a little bit of thinking. I've got this line here. I need to know where the y value is equal to -2. A couple of thoughts. You could say, well, can I find the equation of that line? It's a line. I know it passes through the point 0, 3. The slope of this line can be found by doing change in y, -3 minus 3, over the change in x, 3 minus 0, which gets me -6 over 3, or -2. F of x on this interval is going to be equal to -2 times x minus 0 plus 3. This is for the linear part. You need this equation to be equal to negative 2. If I solve that, we get negative 2x plus 3 equals negative 2. Subtracting 3 from both sides, and then dividing x equals 5 over 2. Okay. I think this part over here probably caught some of you guys by surprise. I hope this first part was pretty comfortable. Here's how they're awarding points. They awarded points for recognizing that 2 plus f of x has to be equal to 0. They awarded another point for solving that equation to get x equals 5 over 2. Now, we're not done. In order to come up with the absolute maximum, they just wanted to know the coordinate where g has an absolute max. Well, what I know is that g prime is only going to be equal to negative 2 this one time. Yeah. Okay. Sorry. So g prime, which equals f of x plus 2, equals 0 only once. Before x equals 5 over 2, g prime is going to be positive. After, it's going to be negative. So g prime is equal to 0 only once. G prime changes positive to negative at this point, which implies g has an absolute maximum at x equals 5 over 2. Sorry, that was written in a place you probably couldn't see it. That would be worth 3 points. That's one way you could go about doing this. I think another option that you might want to consider, and I'm not going to work all the way through this, option 2, you've got your candidate, you've got your endpoints. What you can do is evaluate, find the value of g of 5 over 2, g of negative 4, and g of 3. Each of these you should be able to find, and then you just look to see what's the largest value. Okay, let's keep going. In part C, we're told to find all values of x on the interval negative 4 less than x less than 3, for which the graph of g has a point of inflection, and then give a reason for your answer. Well, if g has a point of inflection, that means that g prime, which we know to be 2 plus f of x, makes a change from increasing to decreasing, or the change is from decreasing to increasing. Well, that's great, but I don't have the graph in front of me that I need. I could also talk about g double prime, which we know is f prime. Well, that has to make a change from positive to negative, or negative to positive. Now, I want to be careful. You might like this definition and say, well, g double prime, that's going to be equal to f prime. Where does that change from positive to negative? The problem is we don't actually see that graph. We see the graph of f. So we're going to have to use the knowledge we have about the graph of f to figure out where g prime, which is 2 plus f of x, changes from increasing to decreasing. Well, we've talked about this before. The graph of 2 plus f of x simply takes this graph here and shifts everything up 2 spaces. I'm looking to see where g prime changes from increasing to decreasing. I can see on my graph that f changes from increasing to decreasing at x equals 0. And if I were to shift this graph up 2 spaces, the change happens at the exact same place. There is no place where g prime changes from decreasing to increasing, so we don't need this statement here. We could just say this happens at x equals 0. Okay, and then g prime, which is equal to 2 plus f of x, never changes from decreasing to increasing. College Board awarded 1 point for this statement about what G prime has to be doing, 1 point for determining that this happens at x equals 0, and we get 2 points. Okay, part D. Part D says find the average rate of change of f on the interval -4 less than or equal to x less than or equal to 3. They then go on to say that there is no point in this interval -4 to 3 for which f prime is equal to the average rate of change. Explain why this doesn't contradict the mean value theorem. Well, let's start with the easy part. Average rate of change of f on that interval, AROC just means slope. F of 3 minus f of -4 divided by 3 minus -4. I can look at the graph. F of 3 is -3. F of -4 is -1. Divided by 3 minus -4, and what are you going to get? You're going to get -2/7. Now, we're told that there's no point on this interval -4 to 3 for which f prime of c is equal to the average rate of change. F prime of c is never equal to -2/7. And they want to know why this isn't a contradiction to the mean value theorem. Well, think about this. What do we know about the mean value theorem? To use the mean value theorem, the function that you're talking about has to be two things. It has to first be continuous. This graph is continuous, but the graph also has to be differentiable. And over here at x equals 0, where we have the transition from increasing to decreasing, we have a sharp point, we have a cusp point. So the reason that this isn't a contradiction, you could say this. Since f has a cusp point at x equals 0, that means f is not differentiable on the interval -4 to 3, which means the MVT, the mean value theorem, does not apply. That's why this isn't a contradiction. My derivative doesn't have to be equal to -2/7 because the mean value theorem cannot be applied. And the mean value theorem cannot be applied because the function is not differentiable. Okay, that's that. Now, for those of you that are hungry for a 5, I'm going to keep pushing. I'm going to do another problem. If your goal is not to get a 5, if you want to stop here, that's just fine with me. And that's good. Use the rest of the time to study, make some flashcards, get going. I'm going to focus on the kids that are hungry for a 5, and we're going to look at a much harder problem and see what we can do. Okay, so this is on page 57 in your special topics packet. And this came from the 2011 AB exam. This was question number 6. And this one is tough. I hope there are still some friends watching the video with me. But this one's going to push you a little bit. Let g be the piecewise linear function on the interval -2 pi to 4 pi, whose graph is given above. Okay? And let f of x equal g of x minus cosine of x over 2. Okay? Part A says find the integral from -2 pi to 4 pi of f of x dx. This is where we're going to have to be careful. What you have is the graph of g. And for those of you that are ready to start having conversations about area, well, that's great, but you don't have the graph of f, you have the graph of g. What do we know? We know that f is actually g of x minus the cosine of x over 2, and that's what I'm trying to integrate. Because of this subtraction, I can distribute the integral and say, let's integrate from negative 2 to 4 pi g of x dx minus let's integrate from negative 2 to 4 pi cosine of x over 2. This guy here is an area calculation. I'm going to look at my graph. Here's the graph of g. Starting at negative 2 pi, going all the way to 4 pi, I need the area. Well, how convenient, I have a triangle. Area of a triangle is 1/2 the length of the base. 4 pi minus negative 2 pi is 6 pi. The height is 2 pi, that's the area for the triangle. Minus, now I need to find the antiderivative of cosine of x over 2. The antiderivative of cosine, this is a integral of cosine kx, is 1 over k sine kx. So for this particular problem, k is 1/2. So we've got 1 over 1/2 the sine of x over 2, and we're going to evaluate from negative 2 pi to 4 pi. Okay, let's keep going. 1/2 times 6 pi times 2 pi is, what is that, 6 pi squared, minus 1 divided by 1/2 is 2, sine of 4 pi over 2, minus 2 times the sine of negative 2 pi over 2, and there is absolutely no way you're going to get me to even think about simplifying this. There's too much trig. There's too many places to go wrong. Here comes the sad news, my friends. This whole thing is worth 2 little points. They awarded 1 point for finding the antiderivative, and then they awarded 1 point for coming up with the final answer. I think they're being stingy with the points here. I would hope that they would be maybe a little more lenient, offer some more points. But in this case, that's not what they did. All right, let's keep going. Part B. Find all x values in the open interval for which f has a critical point. All right, well, what do I know? F has a critical point means that f prime equals 0 or f prime doesn't exist. You have to consider both of these. All right, well, gosh, what do we know? F is g of x, what did they say it was? F is g of x minus the cosine of x over 2. So if you want to talk about f prime, you have to take the derivative. Derivative of g is g prime. Minus the derivative of cosine x over 2, well, that's negative sine of x over 2 times 1/2. Or you could say g prime of x plus 1/2 sine of x over 2. Okay. And we need to figure out where is f prime undefined. So f prime does not exist. Is there any reason why f prime wouldn't exist? Well, let's look at g. What do we know about g? I see a cusp point over here at x equals 0. So if g has a cusp point, g prime doesn't exist. F prime does not exist at x equals 0 because g has a cusp point at x equals 0. Okay? Let's keep going. Let's keep going. The other idea is that f prime could be equal to 0. Well, that means that g prime plus 1/2 the sine of x over 2 has to be equal to 0. And get ready to have your mind blown a little bit here. In order for g prime, well, I don't have an equation for g, I have a graph. How am I going to figure this out? G prime means derivative, it means slope of a tangent line. Well, g is just a line. I can find the slope of this line by doing change in y. So 0 minus, I'm sorry, let's call that point, oh my goodness, 0 comma 2 pi. And this point is negative 2 pi comma 0, my bad. So for values of x between negative 2 pi and 0, g prime is going to be 2 pi minus 0 divided by 0 minus negative 2 pi. Well, that's 2 pi over 2 pi, which is 1. So we're going to get that g prime 1 plus 1/2 the sine of x over 2 is equal to 0. Now this means we're going to have to solve a trig equation. Okay, I'm going to multiply everything by 2. We get 2 plus the sine of x over 2 is equal to 0. When is the sine of x over 2 equal to negative 2? This is not possible. Right, because remember the sine always is going to be between negative 1 and positive 1. Well, that's just for g prime, x values between negative 2 pi and 0. If I look on the interval from 0 to 4 pi, what we get is that g prime, now you find the slope for that line segment, you're going from 0 comma 2 pi to 4 pi comma 0. That slope is 0 minus 2 pi over 4 pi minus 0. You get negative 2 pi over 4 pi. That's going to be, oh, sorry. That's my slope, negative 1/2. Why did we find that slope? That's for g prime. So now we need negative 1/2 plus 1/2 the sine of x over 2 to be equal to 0. Again, let me multiply by 2. I like getting rid of those fractions. Negative 1 plus the sine of x over 2 is equal to 0. Add 1 to both sides, we get that the sine of x over 2 is equal to 1. Where is the sine equal to 1? Well, I know that the sine is equal to 1 when the angle that I'm talking about is equal to pi over 2. That also happens if I do another lap around the unit circle at 5 pi over 2, and it keeps on going. Solving for x, you can multiply both sides by 2. X is equal to pi or 5 pi. Because I'm only interested in values of x between 0 and 4 pi, 5 pi is too big, it's outside the interval. X equals pi is my solution. Let's be real, this was cool. Alright, fellow time travelers, this is me from the future coming back because in part C, when I was filming this video a few days ago, the video cut off and I didn't realize it. Ugh! So here we go, back to finish off what I started. We know that h of x is the integral from 0 to 3x of g of t dt, and they want us to find h prime of negative pi over 3. Well, we talk about this a lot in class. If you want to find the derivative of the function at a point, you first find the derivative of the function. H prime of x is the derivative of this crazy looking integral. And as scary as that might look, there's actually some really nice stuff that's about to happen. The derivative of the integral of a function from a constant to another function, this is that second fundamental theorem of calculus. The second fundamental theorem of calculus says all that you need to do when you take the derivative of the integral of a function from a constant to another function It's g evaluated at the new function, 3x, times the derivative of the new function, which is 3. All that you did is you replaced t with 3x, g of 3x times the derivative of 3. Okay, let me scoot that up. That's h prime of x. Well, what's h prime of negative pi over 3? You're just going to evaluate this expression when x equals negative pi over 3. So that's g of 3 times, negative pi over 3 times 3. G of 3 times negative pi over 3, well, that's really g of negative pi times 3. What's g of negative pi? Go up to the graph. At negative 2 pi, you know that the y value is 0. At 0, you know that the y value is 2 pi. Well, what happens at negative pi? You're halfway between these 2 points. You're on a line. What you need is the midpoint of this line segment. Negative pi, what's halfway between y equals 0 and y equals 2 pi? Positive pi. G of negative pi is pi times 3. That's going to be 3 pi. How did the College Board award points? Getting here is worth 2 points. My guess is if you said g of 3x, they probably awarded 1 point, and then 1 more point for knowing to use the chain rule, and then 1 point for getting to this value of 3 pi, for a grand total of 3 points. That's it. That is the end of this video. I'm going to go back to my life in the future now and maybe come back to the past and fix another mistake that I made. See you later.